Today we're going to practice identifying the properties or the characteristics of functions. The first thing we're asked to do is find the domain. The domain represents the x values that work for a specific function or graph. In this case, we do not have a clear starting or ending point. There are no holes and no vertical asymptotes, so our domain would be all real numbers, which we can notate as negative infinity to positive infinity. Our range, on the other hand, does have a clear start point, which is right here at positive 2. Remember, your range is your y values. Since it starts at 2 and goes down, our y values get smaller. We say our range goes from negative infinity to 2. We always write least to greatest. Our increasing and decreasing intervals are simply where the graph changes from either going up, increasing from left to right, or going down. The easiest way to write our intervals is to label our graph first. The left side, because we use x values to write increasing and decreasing intervals, the left side we write as negative infinity because our x values on this side are at negative infinity. Then we go through and we label all of our x values where the graph changes directions. So here it changes directions at negative 2, it happens again down here at negative 1, and then again up here, we'll estimate that to be about 0.3. So we read this graph from left to right, from negative infinity to negative 2. We go up or increase, so from negative infinity to negative 2, we would write that as an increasing interval. Then from negative 2 to negative 1, we go down. So from negative 2 to negative 1, we go down, so we decrease. Then from negative 1 up to 0.3, we increase again. So we would circle increasing. And then from 0.3 to infinity on the x values, remember these are x values, we decrease. So from 0.3 to infinity, we decrease. Remember, increasing and decreasing intervals we write with the x values. So the left side always represents negative infinity. The right side of my graph is represented by positive infinity. Then I go and write all the x values at my turning points, and those are the intervals in which I write whether it is increasing or decreasing. Since I could take a line and draw on this graph without having to pick up my pencil, there's no discontinuity, so I would say this is continuous. There are no asymptotes or holes or jumps, so I can say it's continuous. The next thing is to write the extrema and label whether they are local or absolute. My absolute max happens at my very highest point, which is up here at negative 2, positive 2. My local max is my other maximum point. It is considered local since it's not the absolute highest point. Happens right here at 0.3, negative 1.3. And then my local minimum happens down here. It is local because I have n's going below it. So my local min happens at the point negative 1, negative 7. Then it asks me if the function is bounded above, bounded below, bounded both, or not bounded. Since we have an absolute y value at 2, that is our very highest y value, that means there are no points above 2, so it would be bounded above. Then our end behavior. On the left side of my graph, I am going down, so on the left side, I am approaching negative infinity for my y values. On the right side, I am going down as well, so I also approach negative infinity for my y values. Remember, for end behavior, you're determining what your y values do on that side of the graph. So now that we have all of our characteristics filled in, we are finished with this problem. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math,
click on my website link here.